Hello everyone, and welcome to a video demonstrating how to find the least common multiples of rational expressions. So finding the least common multiple of rational expressions, to do that we want to first of all completely factor each expression and then know that each factor will be used in the least common multiple at least one time. And the way that we determine that, we use that factor the number of times where the factor is listed the most amount of times in any given expression. So for example, if one of my expressions factored out to be x plus 2 times x plus 2 times x, and my other expression factored out to be x plus 2 times 3, then the least common multiple of those two expressions, we will have the monomials of 3 and x, so 3x. And then we see that x plus 2 is listed in each one of my expressions. However, in the first expression, it is listed 2 times. Therefore, in my least common multiple, it will be listed 2 times. So wherever a factor is listed the most amount of times is how many times it will be used in to find your least common multiple. Now, so far as numbers, there are a couple of different ways we can go about finding the least common multiples of numbers. One way is by completely factoring, or finding your prime factorization of each particular number. So if we look at 8, the prime factorization of 8 using our factor tree is 2 times 2 times 2. The prime factorization of 36 using our factor tree or upside down division is 2 times 2 times 3 times 3. And the prime factorization of 40 is 2 times 2 times 2 times 5. So in our least common multiple, we will use each one of those factors at least one time. So now we look and I see that we have 2's in each one of our prime factorization. However, in 8 and in 40 we have the 2 listed 3 times. That's the most amount of times that is listed in any one of the factors. So in my least common multiple I will have 2 times 2 times 2. Another way you can do that is once I write down 1, 2, I can mark out a 2 from each one of those. Once I write down a second 2, I can mark out a 2 from each one of those. And once I write down the third 2, I can mark the 2 out. And you know that the 2 has been used correctly. 3's, I see that I have 2 3's listed in my prime factorization of 36. So now we'll have 3 times 3. And then that takes care of the 3's. And then I have a 5 that must be used as well. Now I multiply all of those factors and I find that my least common multiple for 8, 36, and 40, or the first number that they will go into, is 360. That's the first common multiple of 8, 36, and 40. Now, the second method that you could use for that is to list the multiples of the largest number until you find the number that all the other two numbers will go into. For example, if I start off with 40, 8 will go into 40, but 36 will not. Then I keep going. 80, 36 still won't go into it. 120, check, won't go into it. 160, 200, and you can keep going in this fashion until you find the number that the other two numbers will go into, and 360 would be the first number that 8 and 36 will also go into. So that would be our least common multiple. Okay. Now if we have the expression 6x squared and 12x to the third, and we want to find the least common multiple of that, again, you can use your multiples of those numbers to find the least common multiple. Always look at your larger number, which is 12 in this case, and see if the other number will go into it. If so, then that's your least common multiple. If not, then you can do more multiples of 12 until you find something that 6 will also go into. So multiples of 6, 6, 12, 18, 24. And multiples of 12, 12, 24, and 36. So you can clearly see that the first common multiple that they have is 12. Now what about those variables? As for the variables and exponents, we always use the highest exponent for any given variable in the expressions. Therefore, with the x squared and the x to the third, the least common multiple for the x's there will be x to the third. So my answer, 12x to the third, will be the least common multiple for those two expressions, those two monomials. Okay, now what if we want to find the least common multiple of these two trinomials? Well, again, you want to factor each expression completely, and then we'll use those factors to build our least common multiple. So x squared plus 9x plus 14, find a couple of factors of 14 that add up to be 9, x plus 7 times x plus 2. X squared plus 3x plus 2. If we factor that, again, we're finding factors of 2 that add up to be 3. X plus 1 times x plus 2. So I know that in my least common multiple, I will have to use x plus 7, x plus 2, and x plus 1. I just need to determine how many times I need to use those factors, each one of those factors. Well, the x plus 7 is listed one time in that first expression, and that's the only time that it's listed, so we will use it one time. The x plus 2 is listed one time in each place, but the most amount of times that it's listed in any one place is just one time. It's listed one time in my first expression, one time in my second expression, so we only use it once. And x plus 1 is listed one time as well, so x plus 1. So that will be our least common multiple, x plus 7 times x plus 2 times x plus 1. Now those can be written in any order. So it could be x plus 1 times x plus 2 times x plus 7. The order of those will not matter because of our commutative property of multiplication. Okay, let's find the least common multiple of y squared plus 16, y minus 2, and 8. Y squared plus 16. Can that be factored, or is it simplified already? That's correct. It cannot be factored. Y squared plus 16 cannot be factored. We can't factor the sum of perfect squares. Now, if that would have been a minus, we could have factored the difference of perfect squares. And there's no GCF there. So it cannot be factored. So our least common multiple now will just be a combination of all three of those expressions. 8 times y minus 2 times y squared plus 16. Each factor is used. That will be our least common multiple. Okay, I hope you found this to be helpful. Thank you.